shuttles, that is NADH shuttles, they move NADH from cytoplasm to mitochondria so that in mitochondria NADH can take part in ETC. Okay, so we have two shuttles. One is mallet shuttle, in which if this is cytoplasm, this is mitochondria, this is inner mitochondrial membrane, then here what is happening? NADH is taken from cytoplasm and NADH is delivered in mitochondria with the help of some enzymes and some molecules, right? And mallet is one molecule which crosses inner mitochondrial membrane. That's why shuttle is mallet shuttle. Okay? Okay, because NADH cannot cross inner mitochondrial membrane. Our second shuttle is glycerol phosphate shuttle, in which what is happening? This is inner mitochondrial membrane, this is cytoplasm, and this is mitochondria. Here NADH is taken from cytoplasm and FADH2 is delivered in mitochondria, right? And this shuttle, glycerol phosphate shuttle, is present in brain and skeletal muscles because this shuttle is quick in supply of ATP. Although it is giving less ATP, obviously FADH2 will give 1.5 ATP. Although less ATP, but it's a quick source of ATP which is required in brain and skeletal muscles. Skeletal muscles are used in flight and fright response, and brain also requires quick supply of energy. That's why this shuttle is present here.